Hi everyone and welcome back. This is going to be our first content lecture in the course. And so today I'm going to be going through some of the basics that we'll need to know as we go through the semester. Before I do that though, I just want to talk a little bit about what I mean when I say statistics in criminal justice and what we're going to be doing and why we're going to be doing it in this course. So what do we mean by statistics? Well, when we're talking about statistics, we're really talking about any sort of use of data or numerical information to learn something about what's going on in the world. And there are many applications for statistics in criminal justice. One of the main ones that you might think about are crime rates, where you're calculating statistics about crime, but that's really just the tip of the iceberg. And as we'll see in this course, there are many, many ways that you can use statistical information in criminal justice. So for example, let's say that you're implementing some sort of new program or policy and you want to know if it works. So we want to know if, some sort of program that we're running in a prison is helping people. Well, one of the best ways to do that is to use statistics. Let's say we want to understand what people in the United States think about capital punishment. Well, the best way to do that is going to be to, use some sort of statistical methods to get that information. And there are lots and lots of examples here. I'm sure you guys can think of some as well. But again, this class is going to be all about using numerical information to learn about the world, and especially in criminal justice applications. And one of the key things that we want to do here, and why we really need to focus on statistics, and why you guys are required to take this class, is that it's really important to be able to use statistics rather than to avoid relying on anecdotes, so things you see in the news or hear about from a friend or family member, or even just common knowledge, because those things don't always reflect what's really going on in the world. And so an example I like is going to be shown by the graph that I'm about to put up here. But the question is, do we live in violent times? And if you ask a lot of people, they will say, absolutely, the world is more violent, it's more dangerous now than it's ever been. But the truth is, even if you take into account, that rise in crime we had earlier in the, in the last century, starting the 60s to the 90s, we really don't live in violent times compared to most of human history. And so you can see on this graph here, this plots the homicide rates in England, where they have been calculated for a long time, going back to about the year 1200. And what you can see here is that there has been a really, really dramatic decline in homicide rates. So for somebody living in England, they are much, much less likely to be murdered now than they would have been to be murdered in the year 1200. Right, so this kind of uses statistics and takes that idea that we live in particularly violent times and turns it on its head. And you can also see there that the graph here ends at the year 2000. So when we think about that big rise in crime that happened, from about 1960 to the 1990s, that's that little tiny uptick that you see at the end of the graph there. So even what we had as a big rise in crime, and many people still think crime is going up, many people still think the world is full of crime, really that's been a pretty small blip sort of in the grand scheme of things. So again, I just like this example because it takes something that's common knowledge for a lot of people, that we live in violent times, the world is more dangerous than it's ever been, and you can see by just plotting some crime statistics that that's not quite the whole story. So as we go through the course, think about what we're doing and think about numbers that you see in the world and how you can make sense of them. All right. And throughout the class, I will be giving you guys examples of things to look out for, examples of statistics in the real world. But for now, I'm going to jump into some of the more boring stuff for today, which is statistical terms. So we're going to be learning about statistics in this class. In order to do that, we all have to have a grounding in some of the terms and words that we're going to be using. So I'm going to go through the definitions on this slide, and then on the next slide, I'm going to go through examples that'll be a little bit more concrete. All right, data. So I'm going to talk a lot about data in this course. Data is any sort of quantifiable information, or information that can be counted. So information about the number of crimes occurring in different years in England would be data. Information about whether or not people support the death penalty would be data. So again, we're talking about any kind of information that involves numbers. right, so moving on now to sort of the more specific things we'll be looking at. An important term in statistics is a population. And a population is all members of some group that you as a researcher or statistician or student are interested in. And so a key idea here about the population is that it is completely defined by what your interest is and what your questions are. If you are interested in what people in the United States think about the death penalty, then your population would be people in the United States. But if you're interested in the number of homicides occurring in England starting from the year 1200, your population might be, the total sum of homicide data from 1200 to current times. And the population would be just that grouping of cases that are out there about homicide. And so a population just refers to all members of some group that you're interested in. And they don't even have to be people. If you're interested in ducks and the migration patterns of ducks, or I don't know if ducks migrate, but whatever, you're interested in ducks, your population could be all ducks. If you're interested in things that happen during police-citizen encounters, your population just might be some, total sum of police-citizen encounters there. So you're not interested in police officers, you're not interested in citizens. The population itself is actually just all police-citizen encounters. So oftentimes you're going to be interested in studying some large group out there that's often pretty undefined. So all police-citizen encounters, right? That's all encounters that have ever happened, that could ever happen, that will happen, ones that are known about, ones that aren't known about. And if you're doing research, it's going to be really, really hard to study every single member of that population. So what we often do in statistics is take a sample. And a sample is a selection of some number of members from a population, so from some larger group. So if you were interested in studying police-citizen encounters, for example, you might take a sample of 100 police-citizen encounters. So you get a little bit of information about each one of those 100 police-citizen encounters, and now you have a sample of 100 encounters. So encounters as a whole is your population, that's what you're interested in, and then your sample is going to be a subset of those, so just 100 different police-citizen encounters that you have information about, and then you can study those 100 encounters. Oftentimes when we talk about samples, we are talking about a sample of people. So another example would be if you're interested in understanding people's attitudes about the death penalty in the United States, you can't ask every single person who lives in the United States. So instead, you might take a sample of 1,000 people and then ask them what they think about the death penalty. And so the idea here is that you're using a sample to oftentimes learn about a larger population, and the sample is going to be just some selection of members from that larger group. All right, so here we are starting big and we're going to get narrower and narrower and narrower with these definitions. So our next definition is going to be a unit of analysis. And a unit of analysis describes what kind of thing your sample or population is made up of. So if you are interested in people's attitudes and you're taking a sample of 1,000 people, your unit of analysis is going to be a person, because your sample is made up of people. Your population is made up of people. If you're interested in police-citizen encounters and you're going to look at a sample of 100 different police-citizen encounters, your unit of analysis is then going to be a police-citizen encounter. So it's whatever your population or sample is made up of. And I find it helpful to think about it this way. If you can't figure out what the unit of analysis is, just say, I'm looking at a sample of blank. And whatever you would fill in that blank with is going to be your unit of analysis. So I'm looking at a sample of college students. My unit of analysis is going to be a college student. All right, so in population, sample, and unit of analysis, we're talking about the larger group. Now I'm going to get even more specific here and talk about an individual member of a population or sample. And this is something that we'll refer to as a case. So if we're interested in police-citizen encounters, we're going to take a sample of 100 police-citizen encounters to take a look at statistically. Our unit of analysis is going to be a police-citizen encounter. And of those 100 police-citizen encounters that we have, a single encounter, a particular encounter, is going to be your case. So of those 100, if you were to select one of those 100, that would be your case. If you're looking at a survey of people, you've got 1,000 people, you're surveying them about death penalty attitudes. If you were to take one of those people, that one person would be a case. And so you'd have 1,000 cases in your survey of people. You'd have 100 cases in your survey of police-citizen encounters, going with the examples I've been talking about on the slides. So a case is just one single member of your population or sample. And then finally here, the last definition on the slide is going to be an observation. And an observation is something that is measured for a particular case. So let's say we're looking at police-citizen encounters. We have our sample of 100 police-citizen encounters, and we're going to look at one of them. So one case in our sample is going to be a single police-citizen encounter. One observation that we might have is whether or not force is used in that particular encounter. So that would be something that we're measuring for this encounter. We have an encounter, and our observation is that force was used in this encounter. There might be another police-citizen encounter in our sample in which force was not used, and so that would be an observation. And for each police-citizen encounter that we have, we're going to have different observations here. So some will have used force, and some will not have used force. And we could measure other things as well. So we could look at, for example, whether the citizen involved in the encounter was intoxicated or not intoxicated. We could look at whether the police officer was respectful or whether they were rude. So these are all things that would be, different across the different cases in our sample, and we would call those different things for each particular one an observation. So again, an observation would be, in this particular sample, did they use force? In this particular case, did they use force? In this particular case, was the officer respectful? And so on. And so each of those things, whether they used force, whether the officer was respectful, whether the citizen was intoxicated, those would be observations that we have about a particular case. So a particular member of that sample. And just to go with the other example I've been talking about here as well, we're looking at attitudes about the death penalty. We have our sample of 1,000 people. A case is one single person. And then an important observation there would be, does that person support the death penalty or not? And if they do, that would be an observation or a particular value that we have for that case. If somebody else doesn't support the death penalty in our sample, the observation that we have there would be that they don't support the death penalty. All right, and so I went through the definitions there with some examples that I talked through, and here I'm going to go through an example that should be a little bit more concrete as well, since you guys all just took my survey. So in the survey that you guys were assigned last week, we have data. So we've got numerical information and information that can be quantified about you guys. And in particular, our data is going to be information about Rutgers criminal justice students' attitudes and experiences. And it's all information that can be counted up and have other numerical things done with it, as we will see throughout the semester. So when we think about data as quantifiable information, we have the responses to the survey being quantifiable information about your attitudes and experiences. In this case, we can say that the population of interest is Rutgers criminal justice students. So maybe I'm interested in learning about how Rutgers criminal justice students in general think about the world and the sort of experiences that you have had. But I haven't asked every single Rutgers criminal justice student what they think. Instead, I've only asked you guys. So my sample would be this class. And so I have a subset of people, subset of criminal justice students taken out of the whole, and I'm going to be looking at that particular subset when I do my statistics and try to learn about what you guys think. The unit of analysis, in this case then, would be a student. So we have a sample of students, so we would say our sample is made up of students, and therefore our unit of analysis is a student. You could also say individual if you want, so you could say we have a sample of people, because you guys are people as well as students, and so you have a sample made up of individual people, so your unit of analysis would be an individual. And so in this one, the key here is that we're looking at what our sample is made of, and our sample is made up of different students who answered the questions in the survey. But you would not say, for example, that the unit of analysis is a class. Because when I look at the data from the survey, I'm going to be looking at responses from individual students, not responses from, a whole bunch of different classes. So again, a whole bunch of different students, not a whole bunch of different classes. So the unit of analysis would be a student. All right, so moving down to our definitions, one more time. A case then would be one particular student. So a case, if you remember, is one member of a sample or population. So in our sample, we have, the 50-ish students in this class, and each student would then represent a case. So you listening at home, you are a case in this sample. And then an observation would be, one particular student's response to a question. So when I asked you guys, for example, whether you support the death penalty, your response to that question would be an observation that would be, attached to you, a case in the sample. All right, so that's a lot of definitions, sort of a lot to absorb, but we will be coming back to these terms throughout the semester, so it's good to just start with this as a base. But I think as we work with them more, they'll also start to gel a little bit better as well. But the next order of business is actually going to be to have some more definitions. And for the remainder of this class, we're going to be talking about variables. And a variable is a characteristic that differs across cases. So again, each case is a different member of a sample, and then a variable is some characteristic that differs across those cases. So in the examples that we've had so far, whether or not force was used in an encounter could be a variable, because it would be something that would differ across different encounters in your sample. Whether or not somebody supports the death penalty would also be a variable, because it's something that would differ among different members of a sample. And variables are really sort of the bread and butter of statistics. We're going to be doing lots and lots of things with variables over the course of the semester, so they'll become your friends. In contrast to variables, there are also characteristics that can be considered constants. So in a sample, a variable is something that differs across cases in your sample, and a constant is something that does not differ across cases in your sample. And we will be doing much less with constants in this class, but it is good to be able to recognize them when you see them. So when we think about constants in the examples that we just had, in a police-citizen encounter, for example, one constant is that each of them is going to involve a police officer. So every police-citizen encounter that you have is going to involve a police officer. So that's a characteristic about the encounter that would not differ across cases in your sample. If we think about the class survey, one constant would be that you guys are all students. So in the survey of this criminal justice class, one constant, so one thing that does not differ among anybody in this class, is whether or not you're a student, because I know you're taking my class, so you're all students. Another constant would be that, you're taking a statistics class. So it'll be something that does not differ among members of a sample. Another constant would be that, you guys all attend Rutgers, right? So something that is the same among every member of a sample is going to be a constant. Something that differs among members of a sample are going to be variables. And there tend to be way more variables than there are constants because there's so many different characteristics that can differ. So when we think about the class survey, the answers to the questions that you gave me, unless everybody happened to give the same exact answer to a question, each one of those questions can be a variable. So not only your attitudes about the death penalty, but your attitudes about the police, the number of times you've been stopped by police, how afraid you are of crime, how much money it would take for you to, eat an entire chocolate cake in one sitting. All of those things are characteristics that most likely differ among members in this class, so all of them would be variables. And then in addition to attitudes and experiences, you can also have other characteristics that are variables. So demographics are variables as well. So things like age, gender, race, where you're from, all those things differ among different people. So in a sample like our class sample, they would also be variables. All right. In doing research, there are also two types of variables that it's important to be familiar with. And you probably encountered these before, but these would be your independent and dependent variables. A dependent variable is a variable that is affected by another variable. An independent variable is a variable that affects another variable. And I think the best way to think about independent and dependent variables is as cause and effect. So if you're thinking about, what causes something else, your cause is going to be the independent variable and your effect is going to be the dependent variable. And in a lot of research, we're going to be focused on understanding sort of things that cause other things, and so we'll be labeling our cause an independent variable, and we'll be labeling our effect a dependent variable. And there is research out there, and there are things we'll do in this class where there isn't an independent variable or a dependent variable because we're not looking at cause and effect. But if we are ever looking at cause and effect, your independent variable is going to be your cause, and your dependent variable is going to be your effect. So as an example, in police-citizen encounters, if you're interested in understanding whether if a citizen is intoxicated, is a police officer more likely to use force? Your cause in that case would be whether the citizen is intoxicated, and your effect would be whether the police officer uses force. So that could be one hypothesis that you might have, so one sort of expectation about what one thing causes another thing. And so your independent variable would be the thing you think is the cause, intoxication, and then your dependent variable would be the thing you think is the effect, which could be police officer use of force. But what we're really going to spend a lot of time talking about today are characteristics of variables. And like I said before, variables are going to be something that we are going to spend lots and lots of time dealing with in all sorts of ways in this class. So what we're going to be starting this class with is just what makes a variable and what are different types of variables. So variables are made up of attributes, and attributes are just possible variable values, that a variable can take on. And so in the example of whether a police officer uses force as a variable, one attribute would be that the police officer doesn't use force, and one attribute would be that the police officer does use force. So the variable is whether force is used, and then the two possible attributes that it can have are that either force is used or force isn't used. Think about whether you support the death penalty. Possible attributes, so possible values that that variable could take on, would be yes, you support the death penalty, no, you support the death penalty, or maybe a third one, you don't know, you don't really have an opinion. But again, those would be different values or sort of different possible responses that you could have for a variable. And in order to use variables in statistical analysis, attributes need to have two qualities. The first quality is that they need to be exhaustive. And here again, I'm going to give brief definitions and then I'll go into more extensive examples in a minute. So for statistical analysis, attributes need to be exhaustive. This means that they need to cover every possible attribute that a variable could take on. And if you're missing one, you're going to have a problem when it comes to doing statistical analysis. Another is that they have to be mutually exclusive. And this means that you can't have any overlap between your different attributes. In other words, if one attribute is true, the other attribute has to also not be true. So in that use of force example, whether a police officer uses force, either they do or they don't. In that case, there are no other options. Either force is used or force isn't used. So you would say that that exhausts all possible attributes that you could have. So it's okay because it's exhaustive. And then the other thing that it would need to be would be mutually exclusive. So if an officer has used force, we can say with certainty that they didn't not use force, right? So saying that an officer has used force excludes the possibility that force was not used. So we would also say that the attributes are mutually exclusive. And to get into even better examples, this is a question that I want you to really think about as I ask you now. What is your absolute favorite thing in the world? Is it bowling or is it kittens? And there's a good chance that if you're watching this video and thinking about your answer to this question, your answer is neither bowling nor kittens. So a problem with this question as a variable would be that it doesn't cover all the possible things that you could have as your favorite thing in the world. So it doesn't exhaust all possibilities. And this means that a problem with this variable is that it's not exhaustive. In other words, favorite thing in the world is a variable, and the attributes that we have listed here, bowling and kittens, don't cover all possible things that you could have as your favorite thing in the world. And this becomes a problem when you try to answer the question, right? So if this were a question in the survey, there would be a lot of people who just wouldn't be able to answer the question, or they wouldn't be able to answer it truthfully. And so it wouldn't be that useful as a variable to us because it doesn't exhaust all the possibilities. The solution to this, if you have a question like this one, is to just include an other category. So now if you're to answer this question, we have exhausted all options. Either your favorite thing in the world is bowling, your favorite thing in the world is kittens, or your favorite thing in the world is something other than bowling and kittens. So now we have a variable, favorite thing in the world, where the attributes are exhaustive. We've covered all possible things that you could have as your favorite thing in the world. So bowling, kittens, or other. All right, so this next example here is going to be getting at the idea of attributes being mutually exclusive. So I want you to think about how you would answer this question. And you can only choose one. Are you a college student? Are you a Rutgers student? Or are you a student in this data analysis class? And so the obvious issue here is that everybody in this class could answer yes to every single one of these questions. So answering college student doesn't automatically exclude the possibility that you're a Rutgers student or a data analysis student. So you could imagine if I included this question in the survey, you would also have had a problem answering it because you wouldn't have been able to choose between only one of these options. Even if I include other. Right, so even other here, we've exhausted all possibilities, but we still have a problem because the attributes for our variable are not mutually exclusive. In other words, if you're a college student, you can also be a Rutgers student, and you can also be a data analysis student. And choosing one of those doesn't automatically exclude the other possibilities. The solution to this sort of problem, might be to just break the question up into multiple questions. So are you a college student? Yes or no? With that question, we have exhausted all possibilities, and the attributes are mutually exclusive. Either you are a college student or you're not. And the same would be true of the other questions as well. But what's key here is that now we're not trying to include them all in the same place, so we don't have any problems with the attributes being not mutually exclusive. And if I had included these questions on the class survey, you would be able to answer them without any problem. All right, so the very last topic for this lecture today is going to be levels of measurement. And levels of measurement also refer to qualities of variables. So this is still part of our variables discussion. And levels of measurement generally describe how much information and the type of information a variable can give you. And there are 4 levels of measurement. The first level of measurement is something called nominal. And when a variable is at a nominal level of measurement, we would say that the attributes cannot be put in order from least to most. And again, I'm going to go through the definitions here, and then I'm going to go through more concrete examples. If a level of measurement is ordinal, we can say that the variable attributes can be put in order from least to most, but you can't be sure that there is the same amount of distance between each of your variable attributes. So there's no distinct distance between them. If a variable is measured at the interval level of measurement, the variable attributes can be put in order from least to most. There is a distinct amount of distance between them that is the same each time, but we are lacking something called a true zero point. And then finally, we have the level of measurement called the ratio level of measurement, where each of those things that I just said is going to be true. So we can put the variable attributes in order. There is a distinct distance between each of the attributes, and it's the same each time. And there's something called a true zero point. But now I'm going to go through, I'm going to talk in a little bit more depth about what each of these different things mean and how you can classify a variable as nominal, ordinal, interval, or ratio. Before I do that though, I will say this is one thing that seems like it couldn't possibly be useful for you to know when we learn it, but then as we go through the class, there's going to be a lot of different things that can be done only at some levels of measurement, but not at others. So getting this down now will actually help you later on. All right, so nominal level variables. Nominal level variables are defined as having attributes that can't be put in any kind of order. So if you were to look at all the attributes that you have for a variable, so all the different values that it could take on, you wouldn't be able to say which is the least or most, and you wouldn't be able to put them in order from least to most, or best to worst, or small to large, or anything like that. And so examples of nominal level variables would include something like race. You wouldn't say that somebody has more race than anybody else. They're just different categories that people can be in. Same thing with gender. You wouldn't say that somebody who is male has more gender than somebody who's female, or vice versa. They're just different categories that people can be in. Profession. You wouldn't say that somebody who is an astronomer has more of a profession than somebody who is a dentist. Instead, they're just different professions that people can have. And then finally, one that I'm going to go through with another example here is going to be type of fruit. You wouldn't say that any kind of fruit is more of a type of fruit than any other. So if you're trying to decide if something is a nominal level variable, the question that you want to ask yourself is, can you put the attributes in order? So thinking about types of fruit, which of these following fruits is the most type of fruit? And that question doesn't make any sense at all. The reason it doesn't make any sense at all is that apples and oranges are just different types of fruit. And you wouldn't say that one is more of a fruit than the other, they're just different types. So if you ask whether something is more or less and the question doesn't make any sense, you would say that you have a nominal level variable. And you could do the same thing with any of these other examples here. You wouldn't be able to take the attributes and put them in order from least to most. So it doesn't make sense to think of having more or less race, more or less gender, more or less of a profession, if you're just looking at different kinds of professions, any more than it makes sense to say that you have more or less of a type of fruit, just comparing these types. So again, there's no more or less here. You can't put apples and oranges in any kind of order for whether, being more of a type of fruit or less of a type of fruit. You just have different categories that are different from each other. All right, so the next level of measurement that we have are ordinal level variables. And ordinal level variables have attributes that can be put in order, but there is no set distance between them. And so what this means is that whatever values your variable can take on, you can put them in order from least to most. But there isn't the same amount of distance between each of your attributes once they're ordered. And the best way to check this, I think, is to think about whether you could do simple math with the categories. Or in other words, are the values that your variable can take on truly numerical? And I'll show you what this means in a second. But examples of ordinal level variables would be something like rank in a police department. So somebody who is a line officer has a lower rank than somebody who is their direct supervisor, who is lower rank than somebody who's the chief of police. But you wouldn't say that there's the same amount of distance between the line officer, the direct supervisor, as there is between the direct supervisor and the chief of police. So you have things that can be put in order, but you have a different amount of distance between each of the different categories that you have. Same thing with something like drink size. So, if you've gone to a restaurant, sometimes they have a really small drink, they have a medium drink that's a little bit bigger, and then they have a large drink that's like the size of a small child. And so in that case, you would definitely be able to put those in order from least to most, but there wouldn't necessarily be the same amount of distance between them. Your small and medium drinks might be more similar to each other, whereas your large drink might be a lot different. There are also a lot of ordinal level questions that are attitude questions, where you might ask something like this. How happy are you? And then which of these statements applies? I'm very happy, I'm somewhat happy, or everything sucks, throw me into a volcano. So how happy are you? Those are the possible options. The first thing that we want to check here is whether or not there is an order to these attributes. So our variable is happiness, our attributes are very happy, somewhat happy, and throw me into a volcano. It's pretty clear from looking at this that you can put them in order. So somebody who's very happy is happier than somebody who's somewhat happy, and somebody who's somewhat happy is happier than somebody who wants to be thrown into a volcano. But what we don't have is the same amount of distance between each of these categories. So you can see that the amount of distance between I'm very happy and I'm somewhat happy would probably be less than the amount of distance between I'm somewhat happy and everything sucks, throw me into a volcano. If you were to say, like, chart this out from like happy to unhappy, very happy and somewhat happy are probably going to be on one side, and then throw me into a volcano is probably going to be all the way on the other side. So in between these different categories, you don't have the same amount of distance. And if you want to check this, a good way to think about it is, can you add I'm somewhat happy and I'm very happy? No, you can't. It doesn't make sense to say I'm somewhat happy plus I'm very happy. These are just sort of different levels of happiness. But they're not actually numerical, and that means that you can't do math with them. So if you're looking at a variable and you're trying to decide whether it's ordinal, you want to check whether you can put the categories in order, and then you want to check whether they're numerical or whether you can do math with them, in other words. So in this case, we can definitely put our attributes in order here, but we can't do math with them. And these rules would apply to the other examples there as well. So you could put your police department ranks in order, but you can't really add a police chief to a line officer. Just doesn't make sense. Same thing with small, medium, and large. You can definitely put them in order, but what's small plus medium? Yeah, sort of just a meaningless question. All right, which brings us to, again, doesn't make any sense to try to add the attributes together, again, because they're not numerical, and because this is an ordinal level variable where the distance between the categories is not set. Which brings to interval level variables. And variables that are measured at the interval level of measurement have attributes that can be put in order, and they have a set distance between those attributes. But there is no true 0 point. What that last point means is that the variable is numerical, so you'll be able to do math with it, it'll have an order to it, but a value of 0 does not mean that there is none of the thing that you're measuring. So as an example, temperature in degrees. You can definitely put the attributes in order. So 10 degrees is colder than 20 degrees, which is colder than 50 degrees. There is a set distance between them, so the distance between 1 degree and 2 degrees is the same as the distance between 2 degrees and 3 degrees, which is the same as the distance between 58 degrees and 59 degrees. And you can test this by saying, can you do math with it? And sure, you can. 5 degrees plus 10 degrees, 15 degrees. It's a question that makes sense that you can do easily. So we have a numerical variable, which means that we're ticking off those two first checkboxes. We have an order to our attributes and a set distance between those attributes. What we don't have, though, is a true 0 point. So if it's 0 degrees out, you know that it's cold, but it doesn't mean that there's no temperature whatsoever, at least if we're thinking in Fahrenheit or Celsius. So instead, a value of 0 has a meaning other than none. And then another example of this one would be something like grades on a test. And so grades is a good one because you can think about a variable as being a test score ranging from 0 to 100%. And to decide how to categorize this variable, we're going to go through those different questions again. So first, can we put these in order from least to most? Yes, we can. You know that of all the test scores you have, you can look at any values and say which is more. So 100% is more than 70%. You know that 3% is more than 2%. Whichever attributes you pick, you can put them in order from least to most, because they're numbers. You can also do simple math with them. So what's 100% minus 70%? It's 30%. It's a numerical variable, and we've tested that by seeing whether we can do any simple math with it. But then the last question here is, if you get a 0% on a test, does it mean that you have no grade? Because if it was a true 0 point, it would mean that we have none of the thing that we're measuring. And in this case, the answer is no. If you get a 0 on a test, unfortunately, you still have a test score. And so that 0 carries information that's something other than none. 0 on a test doesn't mean that you have no test score, in the same way that a temperature of 0 degrees doesn't mean that you have no temperature. So this would be considered an interval level variable, where we have a numerical variable. It's made of numbers. You can put them in order. There's the same distance between each of your different attributes on the variable. So 1%, 2%, 3%, 4%, and so on. But we don't have a true 0 point, because a value of 0 doesn't mean that there is none of the thing that we're measuring. All right. Finally, we have ratio level variables. And with ratio level variables, we're going to be able to say yes to each of these different things that we've been looking at. So we have attributes that can be put in order from least to most. We have a set distance, or the same distance between each of our different attributes. And we also have a true 0 point. And so what this means is that the variable is numerical, it's a number, or it's made of numbers, and a score of 0 means that there is none of that variable. And there are lots and lots of examples of ratio level variables, because ratio level variables are typically anything that you're counting. So something like weight in pounds. 100 pounds is more than 50 pounds, which is more than 20 pounds. And if something weighs 0 pounds, you would say that it has no weight. Distance in miles. The same thing. We know that 100 miles is more than 50 miles. The distance between 1 mile and 2 miles is the same as the distance between 2 miles and 3 miles, which is the same as the distance between 98 miles and 99 miles. So between each of those different tick marks, each mile, it's the same distance. But if you have a distance of 0 miles, you would say that you have no distance, because, you know, something would be right there and there's just no distance to measure. And then as a final example, we might have number of cats. And if you're thinking about number of cats, we can put our cats in order from least to most. 10 cats is, oh. So here, we'll go through this one on the side. Number of cats, ranging from 0 cats to as many cats as you can count, and that's your variable. We can definitely put the attributes in order. 5 cats is greater than 1 cat. It's a numerical variable, meaning that we can do math with it. So 1 cat plus 5 cats, well, now you have 6 cats. And then finally, for this answer to our question of whether we have a true 0 point, you can say pretty definitively that if you have 0 cats, you have no cats. So this would be a true 0 point, where 0 means that there is none of the thing that you're measuring. All right, so just as a quick recap, this table goes through all of the different qualities that you would look at in deciding what level of measurement your variable is. So we have our 4 levels of measurement here. We have nominal, ordinal, interval, and ratio level variables. And then for each of these, you can answer these questions to help you decide what level of measurement you're looking at. So can the attributes be put in order? Can you do arithmetic with the variable? So in other words, is it numerical? And then does 0 mean that there is none of the thing that you're measuring? All right, so that is going to conclude my content for this week, and I'm just going to talk briefly about the problem set 1 before I'll sign off of this presentation. So your first problem set is going to be due this Sunday at the end of the day on Canvas. The problem set includes multiple choice and short answer questions. As I said last week, each of the problem sets will have a slightly different number of questions and slightly different formats, but each week it'll come out to be 20 points towards your grade. You're welcome to start working on the problem set and get through it, and if you can do it without any help from me, that's great. If you have questions or if you want to go over any of these concepts more or see more examples, you can come to the optional review and Q&A session that I'll be hosting on Wednesdays from 2:30 to 3:30. So this is one of those free periods in the Rutgers schedule, which is why I picked it. That said, I understand that many of you guys have other commitments in your lives and you can't always be available on a Wednesday afternoon. So if that's the case, you can also find me on my one-on-one office hours, which will be directly after the session, or just make an appointment. So send me an email and I'm happy to set up a time to go over the problem set and answer any questions that you might have. And of course, you can also email me questions as well. So good luck with the problem sets. And again, if you have any questions whatsoever, please reach out to me on one of these different places that you can find me. And aside from that, have a great week.